You ever get just completely stuck on a problem? I mean, we've all been there, right? You've hit a total wall, and no matter which way you look at it, a solution just seems impossible. It feels like you need some kind of stroke of genius that just isn't showing up. So you have to wonder, how do the world's best inventors tackle these seemingly impossible problems? Is it really just a random flash of brilliance? Or what if there's a system to it? A method to the madness? Well, it turns out there is. It's called TRIZ. Yeah, it's a Russian acronym for the theory of inventive problem solving. And the story behind it is pretty incredible. A Soviet engineer literally analyzed millions of patents to find the patterns, the common threads, behind all these breakthrough inventions. You can think of it like a cheat sheet for innovation, a systematic way to turn those impossible problems into solvable ones. Okay, so let's crack open this inventive toolbox. In this explainer, we're going to unpack 5 of the most powerful and practical principles from TRIZ. These are real tools that you can start using to think about your own problems differently, like right now. First up, we've got Principle 16. It's a beautifully simple idea, and it's all about playing with the intensity of whatever it is you're doing. So here's the core idea. Trying to get something exactly 100% right can be incredibly difficult. So what if you didn't? What if, on purpose, you aimed for a little more than you need, or maybe a little less? The principle shows that sometimes the easiest path to a solution is to just overshoot or undershoot the target. And you know what? We do this all the time without even realizing it. Think about spray painting. It's way easier to just overspray the edges a bit and wipe off the excess than to try and get a perfect line, right? Or how about at the gas station? The pump clicks off, but you give it that one extra squeeze to top it off? Yep, that's you using a little excessive action to get the job done. So we see how adjusting the amount of something can work. But what if the solution isn't about more or less, but about changing your physical perspective entirely? Well, that brings us to our next principle, getting out of the flat world of one-dimensional thinking. This one is all about escaping that two-dimensional trap we so often fall into. If you're stuck on a problem, just ask yourself, can I stack it? Can I tilt it? Can I use the other side of it? You're literally adding a new dimension to your solution. And once you know this principle, you start seeing it absolutely everywhere. A multi-disc CD changer? That's just a stack, a multi-story arrangement. A dump truck? It solves the problem of unloading by simply tilting into another dimension. Even our most powerful compact electronics are only possible because we stack circuits to cram more in. Our next tool, Principle 18, brings rhythm and movement into the problem-solving process. This one is all about using oscillation and frequency to get things done. You know, sometimes a steady, constant force just isn't the answer. This principle suggests that making an object vibrate or oscillate can achieve results that a static, brute force approach just can't. And this can be anything from a simple shake to using really targeted, high-frequency ultrasound. The applications for this are just incredibly diverse. You've got an electric carving knife at home that uses vibrating blades to do all the work for you. In medicine, doctors use focused ultrasonic vibrations to literally shatter kidney stones without making a single incision. And the tiny, precise oscillation of a quartz crystal, that's the very heart of pretty much every accurate watch and clock out there. Okay, so from constant vibration, we're now going to move to controlled interruption. Our fourth principle is all about rhythm and timing. So what happens when you swap out a continuous action for a periodic one? This principle is basically the exact opposite of a slow, steady push. It encourages us to use actions that are intermittent, that pulse, and what's really clever is that the pauses between the pulses, they don't have to be wasted time. They can actually be used to do something else entirely. And periodic action can be way more effective. You use a hammer to drive a nail with repeated strikes, not one long push. A pulsing siren grabs our attention far better than a steady drone. And in CPR, the pause between compressions isn't wasted time at all. It's absolutely essential for the rescue breaths. Now, here's the twist. Sometimes the solution isn't to break an action up, it's to make it never, ever stop. And that brings us to our final principle, which is pretty much the mirror image of the last one. So the goal here is just ultimate efficiency. Principle 20 challenges us to hunt down and get rid of any and all downtime. The question becomes, how can we make every part of a system work at its full potential, all of the time, with zero wasted motion or idle moments? A great example is a flywheel in a hybrid vehicle. It stores up braking energy so the motor can run more continuously at its most efficient level. Or think about inkjet printers. Many of them now print on both the forward and the backward pass of the printhead, turning what used to be wasted return time into productive work. The goal is always the same: eliminate idle time. So, after looking at these 5 principles, what's the big takeaway? It's that invention isn't some mystical, random art. It's a skill. It's about having a set of mental models, a toolkit like TRIZ, that lets you systematically attack a problem from new and unexpected angles. So, I'll just leave you with this question. Think about a challenge you're facing right now, big or small. Could you use one of these principles? Could you solve it by doing slightly too much? By tilting it into another dimension? By making it vibrate or pulse or run continuously? The answer might be a lot closer than you think.